What if your network suddenly stops working and you have no idea why? In this real-world troubleshooting lab, I'll walk you through 4 common network failures, from failed Telnet connections to mysterious ping drops, and show you exactly how to diagnose and fix them like a Cisco pro. Stick around to see how one simple ACL mistake can block all your Telnet traffic. In this troubleshooting lab, I deliberately place Cisco OSes on the PCs and server to really bathe in the configuration of the iOS. Here, we have 4 problems on this topology. The first problem is that PC 1 can't connect to Telnet on server 1. The second problem, again, targets PC 1, which is unable to ping the host name of server 2. The third problem concerns PC 2, which cannot ping the server 1. And the last problem is on PC 2, which cannot connect to Telnet on server 2. We will see in detail the methodology to follow to best troubleshoot these different network failures. For the first problem, we will first check that PC 1 is not able to connect to Telnet on server 1. To do this, we connect to PC 1 and launch a Telnet 10.10.3.30. We can see a timed out error, which means that server 1 is not responding. From PC 1 to server 1, the packets must pass through routers 1 and 3. We will therefore focus our research on these 2 elements of the network. We will start by checking the routing table of router 1 by making it a show IP route. Here, we see that we are using the RIP routing protocol, and that the 10.10.3.0 network is not in its table. It therefore does not know where to send packets destined for this network. So let's check the RIP configuration with the show running config command. Here, however, we can see that the 10.0.0.0 network does indeed envelop the network of server 1. Let's check the state of the Ethernet port that the packet should pass through with the show IP interface brief command. Ports 00 and 10 are well up. The last point that we could check on this router is to see if there is no list access on these interfaces, which would block traffic. A show IP Ethernet interface 00 confirms that no list access is configured on this port, either in or out of the interface. And if we run the same command on port 10, it's the same. Router 1 looks clean. We will now proceed in the same way on router 3. The show IP route command. We show that the routing used is also the RIP and protocol as for router 1. We do not find the network of server 1. The show running config command also proves that it is part of the RIP configuration. So let's check its Ethernet interfaces 20 and 0.0 with the command show IP interface brief. And there. We notice that port 00 is administratively cut, i.e. that an administrator has voluntarily made a shutdown directly on the interface. So we're going to reassemble it by connecting to port 00 and making a no shutdown on it. Now that we think we have targeted the problem, we will try a telnet from PC 1 to server 1. The password is Cisco 123. We are well connected to the server. The telnet connection therefore works perfectly. Let us now move on to the second problem, the one from PC 1 that can't reach server 2 with its host name. To check that we have a problem, we will pin PC 1 its host name with the command ping srv2. Here, we notice that the IP it is trying to reach, 10.10.1.40, is not that of server 2. To confirm, we will connect to server 2 and make it a show interfaces of port 00. Its real IP is 10.10.4.40. For this reason, PC 1 can't pin the host name. If we go back to PC 1 and ping the IP of server 2, it works very well. So there is a configuration problem on the host file of PC 1 to display only the host part of the current configuration file of PC 1. we will do a show running config followed by a pipe and include host. Note that the name SRv2 is associated with the wrong IP, 10.10.1.40. So, we'll simply modify the configuration with an IP host, SRv2 10.10.4.40. Now, if we restart a ping of the server name from PC1, it should work. Let's move on to the penultimate problem, that of PC2, which can't ping server 1. As for the first problem, we will proceed in the same way and in the same order. A packet that goes from PC2 to server 1 must pass through routers 2 and 3. As we had already checked router 3, we will just check router 2. Let's start with its routing table with a show IP route. It's still the RIP protocol, and this time we can see the server's network. It's simply because we solved the first problem by going up the interface, which was down. The routing is therefore clean, no need to check its configuration. You can go directly to the state of the router's Ethernet ports with the command show IP interface brief. Here, ports 00 and 140 are well up. Let's see if there is no access list to configure on these two ports with the command show IP interface. No access list for port 00, and the same for the 10 port. Router 2 is therefore clean. As we know that server 1 is well started, since PC1 can reach it without any problem, and since routers 2 and 3 are configured correctly, we can assume that the problem would be targeted directly on the PC2. So let's check the IP configuration of the PC2. It's actually the only one that is really a PC on the TP. Here, we can see that the gateway that is configured does not correspond to a topology device. The default gateway should be the IP of the interface of the nearest router. It would therefore be that of the 00 Ethernet interface of router 2, the 10.10.2.1. So we're going to change the default gateway IP and restart our ping. This time, it works well from start to finish. Let's move on to the last problem to solve. PC2 is unable to connect to Telnet on server 2. If we launch from PC2 a Telnet 10.10.4.40, we have a timeout error. As for the first problem, we'll try to ping the same IP. Here, the Telnet doesn't work, but a ping works. The Telnet tool uses the TCP protocol to establish its connection. It does so on port 23. Ping, on the other hand, uses the ICMP protocol. Since it works, you could think that port 23 is unreachable. Between PC2 and server 2, there are routers 2 and 4. The 2 has already been checked, so we will focus our research only on the 4. With a ping that works from end to end, there is no routing problem. So let's see if there is a list access configured with a show IP access lists. There is indeed one, which is called server. And in addition, line 20 prohibits TCP packets that would do Telnet. It remains to be seen if it is applied on a router interface. From PC2 to server 2, packets pass through ports 10 and 00 of router 4. Let's start by doing a show IP interface, Ethernet 10. There is nothing on this side. We continue on the other port with a show IP interface, Ethernet 0. Here, the server list access is present out of port 00, which explains why the ping goes through, but not the Telnet connections. As it's an extended list access, we'll be able to delete line 20 and add a line as well in 20 without rewriting the whole ACL. We therefore connect to the server ACL with the command IP access list extended server. Line 20 is deleted with only a no 20, then we will allow TCP traffic with a 20 permit TCP any EQ 23. Now, if we try a Telnet connection from PC2 to server 2 again, it should work. The password is Cisco 123. And that's it for this TP, which was, it must be admitted, a bit long. I'll see you soon for the rest of the program after a well-deserved break.